This is section 8.2, rational exponents. So what we've got here is a new set of properties. We are going to be allowed to have fractional exponents. Now, if you just look at this definition and this definition, if you look at these and you apply this property number 7 that we learned back in 5.1, I told you these were never going to go away. This says a power raised to a power, you multiply those exponents. Now look, even if we haven't talked about what the fraction part means, you can see that these are true. This is 1 over n to the m. Remember that would be m over 1. And if you multiply those together, you do get m over n. The same thing happens right here. M times 1 over n is m over n. So you should be able to see, even without a definition, that these two things are equivalent to this. Now, what does the fraction part actually tell you? Well, it means you're going to have some kind of root. The denominator tells you the index. The numerator, right here, the m, is the power on the exponent. Now, because it can be written either this way, which tells you to take the root first and then raise it to a power, that would be here, root first, then power. Or you can raise it to the power and then take the root, which is right here. Now, both of these are very useful. It kind of depends on what number value you're dealing with as to which of these is easier. Okay? So what we're going to do is we're going to look at simplifying the following ones. Okay? So if I have 729 to the 1/3 power, this denominator tells you it's going to be a cube root. This numerator tells you it's going to be written to the first power. Okay? So if I take the cube root of 729 and then I raise this to the first power, or I could think of it as the cube root of 729 to the first power. I'll get the same answer no matter what, obviously because it's to the first power, but even if it's not the first power. Okay, so you can use your calculator if you don't know that. The cube root of 729 is 9. So this is equivalent to 9. Now you can use the exponent button on your calculator and the fractions. So if I hit 729 and then I want to raise it to an exponent, and then I can use my fraction button to enter 1/3, and it will give me 9. I do want to warn you about this. There are some glitches in the programming of some calculators when you use fractional exponents. Most of the time it works, but there are a few glitches. If you get something that seems a little bit weird, try it another way. You have options here. Okay, so look right here. I have 64 over 81 raised to the 1/2 power. Okay, now we're going to have a property that says you can take the root of the top over the root of the bottom. But it also follows from right here, property number 9. This says if you have a fraction raised to an exponent, you can put the exponent on the top and on the bottom. Since this is a root, this would say I could take the root of the top over the root of the bottom. So that's where that property is going to come from. Now this tells me that it is a square root. Remember, a square root has an understood index of 2, and I'm going to be raising it to the first power. So I can think of it as the square root of 64 over 81, and then raise that to the first power. Or I can think of it as the square root of 64 over 81 to the first power. Those are equivalent. And either which way, you take the square root of the top, 64, take the square root of the bottom, 81, so you get 8 over 9. Okay, remember this is an understood index of 2. Okay, so let's look at 100 to the 3/2 power. So this is going to be the first time we have an actual exponent other than 1 in there. This is going to be a square root, and we're going to raise it to the 3rd power. And here for the first time, you're really going to see the difference between these two options. Okay, so the first way would be to take the square root of 100, and then take that answer and raise it to the 3rd power. I could also take the square root of 100 to the 3rd power. Well, the square root of 100 is an exact root. Square root of 100 is 10. And then if I raise 10 to the third power, that's going to be 10 times 10 times 10, which gives me 1,000. Not so hard to do in my head. Okay, so let's try it this way. I want to find the square root of, and I need to multiply 100 times itself 3 times. 100 times 100 times 100 gives you the square root of 1 million. And you probably can't do that one in your head, so let's take the square root of 1 million. Is that right? Yeah. And then that gives me 1,000. So you can see that they are equivalent. Now, generally speaking, for me, if I end up with something that is an exact root, it is easier to take that root first and then deal with the exponent. If it's not an exact root, it is often easier to do the exponent before taking the root. This, if you take the root first, it will give you a smaller number, and then it's easier to raise to an exponent. But if it's not an exact root, then this gets even uglier, so it's easier to do the exponent first. But it is a personal choice. They both work. Okay, so let's keep going. I have negative 144 inside parentheses raised to the 1/2. Remember, whether the exponent is, the sign is inside the parentheses or outside the parentheses does matter when you're using an exponent. This is a square root to the first power, so this is equivalent to the square root of, since the negative is inside, the square root of negative 144. Now we will learn how to deal with this special case, the square root of a negative, in the last chapter. But for right now, if you enter it exactly the way it is, if I enter the square root of negative 144, I get domain error. If I enter it like this, inside the parentheses, and then raise it to the 1/2 power, I also get domain error. This is not a real number. Remember that we have issues every time our index is an even number, if we have a negative on the inside. If the negative is on the outside, it's okay. If it's an odd index, it's also okay. Okay, so let's take negative 8 over 27 to the negative 2/3 power. Now we do need to remember what a negative exponent does. A negative exponent, right here, takes it and moves it to the bottom. The other way we've thought about it is right here. No, actually right here. If we have a fraction raised to a negative exponent, we can take the reciprocal of what's inside and then raise it to that positive exponent. Okay? So since this is a negative exponent, I can take the reciprocal of this, and a reciprocal, if it's negative, they're still negatives. Okay, so this is the equivalent of negative 27 over 8 raised to the positive 2/3. Okay, because it doesn't matter what's inside, we just take the reciprocal of it and change the exponent on the outside to a positive. Okay, so this is going to be a cube root. And it's okay, since it's a cube root, our index is going to be odd, so a negative is going to be okay. And then we're going to raise it to the second power. So since it's a cube root, I'm trying to decide now whether I want to take the root first or the root second. And remembering I can take the root of the top over the root of the bottom. This is a perfect cube and this is a perfect cube. So taking the cube root first is probably going to be easiest. So let's say I take the cube root of negative 27 over 8, and then I'm going to raise this to the second power. Okay, the cube root of a negative number is negative. The cube root of 27 is 3. The cube root of 8 is 2. So I have negative 3/2 squared. Now the negative is on the inside, and it's being squared, so this means it's negative 3/2 times negative 3/2, which is going to give me a positive number. 3 squared is 9, 2 squared is 4. My overall answer is 9/4. Now let's see if our calculators would give us that. Let's clear this. If I open parentheses and enter negative 8 over 27, close parentheses, raise that to the negative 2/3 power. And let's see if it gives us the answer. Yes, 9/4. Now, I do want to point out that, yes, your calculator will do a lot of these, but it won't do all of them, okay? So you still have to know how to do this stuff by hand because there are limitations in the programming here.